Okay, let's look at the next subtopic, which is triangle proportional segment theorem, or you call it side splitter. Another name is side. Don't call it that, call it side. We call it side splitter theorem. So this theorem states that if a line parallel to any side of a triangle intersects the other two sides, then it divides the sides proportionally. So I'm saying that if you are given a triangle, then assuming you are given this triangle and you have a line parallel to to any of the sides and also intersects the other two sides. So I'm saying that assuming AB is parallel to CD, we call it angle. That if AB is parallel to CD, that it divides the sides proportionally. I'm saying that AE over AC must be equal to BE over BD. So that's what the theorem states. It's very, very important. To prove this, let me just do a quick proof. So looking at this triangle, we'll use similar triangle to prove this. That's why it's under this. You know that this angle corresponds to this. Why this corresponds to that coincidence? The other one corresponds to this. So we have this triangle EAC is similar to triangle ECD, similar to triangle EAB by angle similarity theorem. So let me just do a quick proof on that. So let's call here A, B. Let's call here C, D. So you notice that A plus B over A. Yes, because if A plus B corresponds to A, the bigger triangle, this size corresponds to this. Why C plus D is over C, sorry. So because they are similar, angle similarity postulates. So it's by angle similarity postulate. So the next is to simplify. So this is AA, so we have B over A equal that, which implies that B over A must be equal to D over C, which is correct. B over A or A over B, or write it A over V must be C over D. So proved. So that's what the theorem is. Very, very simple. We've used similar triangle theorem to prove that. Also, there is the next one, which is mixed segment theorem. The theorem states that if a segment, that if you have a triangle, that a segment, if a segment joining the midpoint, assuming you have triangle A, B, C, D, E, that if D and E are the midpoints of this, so I'm saying if here is this, if here is this, that this line, that segment joining the midpoint is always parallel to the third side. So I'm saying that it will be parallel to the third side, so it's parallel to the third side and also has the length equals half of the third side. So I'm saying that if here is 2x, here is x. So that's what mid-segment theory says. It states that a segment joining the midpoint of a triangle, the midpoint of two sides of a triangle, is parallel to the third side and also has a length equal to half of the third side. So that's what the theorem states. So we can still prove this. Assuming I call here, maybe call here A, B. Sorry, here is also A, that are equal. You notice that 2A over A, yes, for the bigger triangle is 2A, for the smaller one is A, must be equal to 2A, which is 2x over. Remember, let's assume that here is what we are looking for. So let's assume as DE as y. Let's call it y. You get, I said let DE be equal to y. So we are looking for y to show that it is always x. So from the diagram, this is AA 2, 2, so which implies that y is x. So we are correct. So y here, D is x. So that's what the theorem states. So let's go over to some example question on similar triangle as a whole. Okay, look at the first example question. The first question, we are given, find the value of x given this. Look, remember, they did not say whether they are similar. Once you see anything of this form, a triangle, you have to look at maybe the similarity, because you are seeing some size and angle. So looking at this, you notice that this angle is the same thing as this by vertical angle theorem. Is correct. Again, this line is parallel to this, so meaning that if I have here as second angle here also by alternate interior angle theorem. So from here, the third one, which is, let's use 3 hatches, must be equal to this, because since the two are equal, the remaining must be equal also. So looking at it, since we have this triangle, we have side angle side. So from this, we now say that maybe 3. So EC corresponds to, check, these 3 hatches, this is 1. So which one has 3 hatches and 1 here? Which is 1, 3. So over 8. So 3 corresponds to 8. Must be equal to, for the small, which is 6 over, check, this 2, 3, this 2, 3. So x. Therefore, remember, we are looking for x, 2 here, so x must be 16. 3 times 2, 6, 8 times 2 must be 16. So x is 16. Our answer is 16D. So the next question we are given, remember I told you is by, why this is so is by side SAS similarity. Must theorem y, similarity theorem. So we solve this by this theorem. So the next one, we are given this, that we have to find the value of y if angle BAC is equal to EDC. BAC, so assuming here is this, must be equal to EDF. Okay, here. So by looking at this, this is parallel, this line AB is parallel to E, so meaning that if here is 2 hashes, here should be 2 hashes by alternate interior angle theorem. So since we have 2 similar triangle by, okay, these 3 remaining side, this one will always be 3. So we only can solve this thing by SAS. Check, this side angle side, this is also side angle side. So we need to be careful here. So we are looking for y, so let me make y to be in the numerator. So y over, so y corresponds to which side? So I'm saying that triangle ACB is similar to triangle FED. So where is y? This is y, so it corresponds in the other triangle. This is 2 and 3. 2 and 3, so it corresponds to 5. Equal to the other one. This 1 and 3, which is 6 over. Where is 1 and 3? 1 and 3, which is 8. Therefore, I told this by SAS, Similarity Theorem. Therefore, we are looking for y. Y is now 6 times 5 over 4. This is 2. 3 times 5 is 15 over 2. So the answer is B. So you need to be careful here. Don't misplace sides. So the next one, we are asked to find x in terms of y. Find x in terms of y. Looking at this, the triangle are similar. I'm saying that triangle AED is similar to triangle ABCY. By which theorem? Check. It will be angle. Because here is the same thing. Here is here by corresponding angle theorem. So by angle similarity theorem. Postulate, sorry. It's not a theorem. So which implies that, check, okay, remember we're looking for find x in terms of y, so we are making x the subject of formula, so x must be on top over, so x corresponds to y for the bigger triangle, which is 4 plus half. Yes, the bigger one must corresponds to 4. Yes, so which is 4 and a half means 9 over 2, so 9 over 8. Therefore, x must be 9 over 8y. So the answer is 9. X is 9 over 8y. So the next question, we ask if angle ABC equals that, and there are 90. So I'm saying ABC. So here is 90. They say here is 90. Here is also 90. And finally, here is 90 from the given information. So we have asked to find the value of BE. That's the total BE here. So from here, it seems we will solve this using similar triangle. From here, this is 5, this is 3, so here it should be 4 by Pythagorean theorem. So, but let's call here, assuming here is theta. Remember, angle sum, that's angle on the straight line. This is theta, this is 90, so the remaining must be 90 minus theta, since one is theta already. It's 90. And here, by angle sum theory, here is a theta. If you add everything, it should be 180. This is 90, so this should be theta. And also here, since here is theta, here should be 90 minus theta. So we have a similar triangle. So we can use right triangle similarity theorem here. So we are saying that from here, we are looking for BE. Before we know BE, we need to know CE. So let's call CE x. So we are looking for S. I'm saying that if x corresponds to, remember, 90 minus theta 90. So which one? Because these two triangles are similar now. So where is 90 minus theta 90? 90 minus theta 90, so it's 3. S corresponds to 3 here. The corresponding angle, corresponding side. So y, again, which one? Because we are given this here, 2, theta 90. Where is theta 90? Here, so 4. So I'm saying that 2 over 4. So which implies that x is 2 over 4 is half. So must be 3 over 2. This is half, so 3 over 2. So x is 3 over 2. So finally, we are looking for, remember, why is this thing correct? Because of right triangle similarity. Always tell them why. Tell us why. Similarity theorem. So therefore, we are looking for BE. BE is just the addition 4 plus 3 over 2. And 3 over 2, this is 11 over 2. 8 plus 3 is 11. So the answer is 11 over 2. So the next one, we We have to find the value of x plus y. It has to find the value of x plus y.